Hello my friends, welcome to this new practical activity and the first practical activity actually of part 3, classification. I'm super excited, as you might hear by the sound of my voice, because this is one of my favorite parts, and actually you will see that the case study we will do together is pretty fun. So I can't wait to start. Welcome back. And so now here we go. We are about to enter a new branch of machine learning where this time we won't predict a continuous numerical value like in part 2 regression, but this time we will predict a category, a class. Like for example, a binary variable 0 or 1. One classic example is actually to do classification to predict a tumor, whether a tumor is benign or malignant. And this is actually the case study we'll do at the end, when I will teach you on how to select the best classification model. But that will come at the end. First, we will do a fun case study with which we will learn how to build each of our classification models. And there you go, my friends. It is in this tutorial that I will explain the problem of this case study. Alright, so before we start, let's just make sure once again everyone here is on the same page. So right before this tutorial, I gave you the link to this folder containing all the codes and data sets in the 10 parts. So make sure to connect to that link. And now we should all be on the same page. And there you go, we're going to go into part 3, classification, to tackle our first model, logistic regression. I hope you enjoyed the intuition lectures, and mostly that you're now ready to put your well-learned theory into practice. And we're going to put it into practice first with Python, with which we're going to re-implement from scratch and step by step the whole logistic regression implementation. So as you can see in this Python folder, you have two files. First, that logistic regression implementation in IPYNB format, which you can open with either Google Collaboratory or Jupyter Notebook. And you have the dataset, which is called social network ads. So let's open it. And now let me explain what the problem is about. All right, so let's imagine our favorite car company. I won't mention a name here because I don't want to do any kind of advertising. But let's imagine your favorite car company, and let's imagine that you are a data scientist for that company. And your mission, should you choose to accept it, is to predict which of your previous customers will buy a brand new, beautiful SUV just created by your favorite car company. All right, so your favorite car company has just released this brand new, beautiful, irresistible SUV, and the general manager of this car company has asked you, the most talented data scientist of the company, to predict which customers will buy that new SUV, with the highest conversion rate. And to help you, because, this general manager has some minimum data science skills and knows and understands that in order to predict this, you need data, right? You need data on which to train your classification model to predict what needs to be predicted, meaning which customers will buy that brand new SUV. And so there you go. That's exactly the data that your general manager gave you. And in this data set, each row corresponds to different customers. And for each of these customers, there you go, I'm about to reveal the features and the dependent variable. For each of these customers, this general manager collected the age and it collected the estimated salary because, when a customer buys a new car with some kind of credit or whatever, it has to provide the estimated salary in the form. So that's how it got the estimated salary. And finally, that's your dependent variable, of course, the purchased variable telling whether or not these customers have bought previously some older SUVs of this car company, right? So this car company has basically many makes and models of SUVs, and all the zeros and the ones that you see here for each customer is saying whether or not these customers have bought one of these previous SUVs, so that your model will be trained on this dataset. And for new customers, having a different age and a different estimated salary, we will predict if yes or no they will buy that new SUV. Okay, so of course in this dependent variable purchased, 0 means that the customer didn't buy any previous SUV, and 1 means that the customer bought some previous SUVs, all right? And therefore, all the future predictions that will be equal to 1 will probably mean that the customer has a high chance to buy the new SUV if, of course, we offer a great deal. And finally, once we predict the customers that are going to buy the SUV, well, the final step of the strategy will be for the advertising team to post ads of this brand new SUV on social networks, and these ads will be targeted to the customers where we predict one, where we predict that they're going to buy that new SUV. All right, so you see the idea? The predictive model will target your customers, and then the advertising team will use the results of this predictive model to optimize the targeting of future customers. And that is why, the name of the dataset is called social network ads.csv.